Oh, hello everyone. Welcome back as we continue this amazing journey into the world of fractions. Today we're jumping in. We just got done with some sums and differences, so we are going to start talking about products of decimals, or as we remember, the answer to a multiplication problem, in this case, fractions and products. We're going to be talking about multiplication or the products of fractions and whole numbers. So as always, as you can see, we always like to break these things down so we can make sense of what this says to us. So again, as we can see, products, multiplication, right? So we're going to be using some multiplication with fractions, which in this case are going to be the units smaller than 1, right? Because remember, if I had any fractions larger than 1, then it would be a top-heavy fraction, which is not the term we're using here, or it'd be a mixed number. And I'm not using either of those terms here. So we are focusing just on fractions like unit fractions or any fractions smaller than 1 and the whole numbers themselves. And if we think again about what whole numbers are, oh, here, wait, let's show a couple fractions like 1/3, right? 2/3, 1/4, 1/100th, 32nd, 50th, whatever, like anything that is smaller than 1 whole, because remember 1 whole would be all of it. For example, 50 out of 50 or 50 divided by 50 equals 1 whole. So that's equal to 1, and that's not what we're doing. And then whole numbers as well, what I just said, 1 whole. So a whole number could be like 1 or 3 or 26, right? Any of those numbers that do not have decimals or fractional parts attached to them. So the whole number is just the number in its entirety, all of it, with no extra pieces. And remember, those extra pieces could be decimals or fractions. Okay, so basically, what does that mean? Well, that means then we're going to be looking at things like fractions, let's say like 1/5 times a whole number like 7. So we're going to be solving problems like this here. So let's go ahead and just dive in and make sense of how to do this work. It is really based on prior knowledge you already have, and that prior knowledge would be around products and multiplication, because the concept of multiplication doesn't change just because our units change, right? Whether it's a fraction or whether it's a whole number, it is the same thing. An example of that, right, would be, again, if we go back to understanding what we know about multiplication is, let's say we have something like, oh, I don't know, 2 times 6, right? And what that's stating here is I have 2 groups of 6. So that could be written as one group of 6 plus another group of 6, which is 12. It could also be stated that I have 6 groups of 2. So 1, 2, 3, 4, 5, 6, which would be 2, 4, 6, 8, 10, and 12. Right? Multiplication being that concept that we're skip counting. It's that's all multiplication really is. It's a more efficient way that we skip count numbers. So again, thinking about equal groups of something, right? 2 equal groups of 6 get me 12. 6 equal groups of 2 get me 12. And again, that order doesn't change. That's the commutative property of multiplication. It doesn't really change. 5 times 3 is the same thing as 3 times 5. So it's how you want to view it. Do I want to picture this as 5 groups of 3 or 3 groups of 5? Whatever helps me skip count. I tend to be able to skip count by 5s a lot better than 3s. So I'm just going to say 5, 10, 15, right? 1, 2, 3 groups of 5. Or again, if I wanted to skip count by 3s, I could say 3, 6, 9, 12, and 15. That'd be 1, 2, 3, 4, 5 times, which gets me right. So that right there is that concept of multiplication and skip counting and repeated addition in a way that allows us to think about multiplication. Now, why we took time to talk about that and refresh our brain on that is because this is exactly what happens when we start to think about the multiplication of fractions. Because if I take this concept here, this equation, this expression, I should say, right? It actually doesn't have an equal sign or a variable or an answer. So it's an expression. If I take this expression and I want to solve it, well, the concept here is telling me that I have 4 groups of 1/6 each. So I could actually rewrite that as saying, oh, I have 1/6 plus another 1/6 plus another 1/6 plus another 1/6, right? I have 4 of them. as stated right here. 1, 2, 3, 4. And if we now break down what we know about the addition or repeated addition of fractions, is that when the denominator is the same, we just slide it on over and then we add our numerator. So 1, 2, 3, 4. Oh, okay. Well, 4 times 1, 6 equals 4, 6, which makes some sense because I have 4 1/6 units, right? 4 1/6 units. If we thought about that in our as an array, right, rows and columns. Well, let's see here. I have, let's see, 4. We have 1/6 across the top. Let's do that. So let's think about breaking that down into sixes. 1, 2, 3, 4, 5, 6, right? So my 1/6 is really here. And then I would have 4 units going across that, which would be 1, 2, 3, 4. So again, I have 4, 6 when I look at my model there. And we'll explore this. This will make more sense as we get into like how to model this, but with fractions and whatnot. But for now, let's kind of move on with what we're doing here with this repeated addition, how this makes sense. So here's another problem here. So if I look at this, I have 3 times 1/8, which just tells me again, I have 3 groups of 1/8. So that just means I have 1/8 plus 1/8 plus 1/8. Well, again, those are all the same. So I'm going to slide that on over and get 8. And then I'm going to add my numerators. 1, 2, 3. Oh, okay. So I wonder if we're already starting to see a pattern. 3 times 1/8 is 3/8. 4 times 1/6 is 4, 6. So far at this point, none of my fractions are top heavy. So my answers are very acceptable. So this is looking good. Okay. So let's continue the trend. 4 times 1/7. So go ahead and kind of pause it now and try that out and then come back and see how did that go. So welcome back. I hope you paused and already solved this and have an answer. Let's check our work. Again, our multiplication sentence is stating that I have 4 groups of 1/7. So that just means I have 4 1/7. So I can look at that again as a repeated addition. Sorry, let me set that up there. Okay. And then again, repeated addition or addition of fractions is I don't need to add the size of the piece. It just stays the same. Slide it over. And then we add our numerators. 1, 2, 3, 4 is 4/7. Oh, yeah. Again, are we seeing a possible pattern? This is going to come in handy soon. What are we noticing? Right? Cool. All right, let's continue this journey. This is a lot of fun. So let's come into here. Oh, okay. Wait, so now this is saying I have 2/3 groups of 5. That feels confusing to me. So I'm going to use the commutative property of multiplication. I'm going to flip this around, and in my head, instead of worrying about drawing or writing 2/3 of 5. Yeah, whatever. I'm going to look at it the other way. Commutative property is going to help me out. And this is really just saying, hey, I'm going to take 5 groups of 2/3. So again, 1, 2, 3, 4, and 5. Now, again, we've been kind of using these units of 1, these unit fractions. In this case, I do not have a unit fraction. I just have a fraction, but it doesn't change the fact that all my denominators are the same. So lucky me, I'll just slide it over there and then I'll add my numerator. Well, 2, 4, 6, 8, 10. Oh yeah, 2 groups of 5, 10. And my denominator doesn't change. Patterns. Ooh, I hope we're seeing it. But now, as you can see, I end up with 10/3, which technically just means here, I have a top heavy fraction. So I do want to convert this into a mixed number, right? This is not that acceptable answer. We want to convert. Now, remember, every fraction is a division problem. So this is literally just saying I have 10 and I'm dividing it by 3. Or again, I have 10 pieces, but 3 make the whole. So what's going to come out of that? Well, let's see here. 3 times 3 equals 9. And it gives me 1 left over. Oh, so there you have it. This is the same thing as 3 wholes and 1 left over out of 3, because again, my denominator is not changing. So 2/3 times 5 is 3 1/3, which is also kind of a curious concept as we start to think about what kind of products we're getting, because technically I started with 5, I multiplied, but my answer was smaller than 5. It was actually 3. So that's something to be thinking about, like the whole and multiplying by 1 and the identity property of multiplication and where that comes into play. So that's fun stuff to be thinking about. All right. So, okay. Okay. Well, 4 6 times 21. I mean, what we've been doing here is this is telling me that really I'm going to take 4 6 and I'm going to write it as many times as I have it, but this is 21. And I don't know if I want to sit here and write this 21 times, right? And I'm going to be here a while. So I'm actually going to stop and think about what have I noticed so far about the work I've been doing that will help me be efficient. I'm going to actually jump back here and look at a couple of these things. And again, talk about that pattern. So in this scenario, right, yes, we modeled it and that worked really good. But one thing I noticed is that it's like adding fractions. My denominator isn't really changing in this case because I'm multiplying it by a whole number. And really what's happening across the top is that it looks like that's really the multiplication that's going on, right? 4 times 1 is 4 out of 6. 3 times 1 is 3 out of 8. 1 is 4 out of 7. Even in this one, ooh, I'll use so much color happening on this one. 2 times 5 got me 10 out of 3. So this is all kind of working out. So noticing here that if I multiply my numerator by the whole number and then keep my denominator the same, that's going to get me to what I'm trying to achieve. So this one, although it looks kind of big, it's just a little math. Oh, I actually, to solve this, can just take 4 times 21, right? Because there's 21 holes, and each one of those holes has 4 pieces. So I just do a multiplication problem of that. Let's see. I'm going to go with partial quotient. So 1 times 4, and then this is a 20 times a 4. So 1 times 4 is 4, 2 times 4 is 8, and a 0. So that gives me 4. So this equals 84 out of 6. Now I got some more steps, and then we're understanding how to use multiplication and division facts and fluency really handy for all these other skills along the road, because now you see I have a top-heavy fraction. And that top-heavy fraction is really stating that I have 84 being divided by 6. So I can actually put this and solve here. Let's see, 6 times, what do I know? Let's see, 6 times 10 is 60. It's 24. 6 times 4 is 24. Oh, this is interesting. 4 6 times 21 is actually equal to 14 holes. So it doesn't even becomes a whole number, and that's okay, right? That's a possible answer. These are all equivalent. 48 6 is the same thing as 14, because if I had, wait, did I say 48? Sorry, 84 6, the same thing as 14. So this is the journey we're going on. And again, as always, like, it's not expected we know this right away. It's really about us just kind of pulling things together and making sense along the journey. So day 1, what are some things we noticed? Well, I noticed that when multiplying, wow, let's just do another page. I noticed when multiplying fractions with whole numbers, I'm really just taking my whole number and by the amount of pieces I have, which again makes sense because this is saying I have 3 groups of. So I can model it like this, right? Look at that. I'm actually going to end up with 1. But I can also just think about, oh yeah, well, that's just multiplication as well. So I can multiply my numerator by the number, my denominator stays the same, and then always asking that question, can we convert? Well, this is 6 out of 6, which is the same thing as 1, which is true. So 2 6 times 3 equals 1. Now the last piece to leave you with later as we go, but it never hurts to be thinking ahead of time, is this is a very interesting moment because we know multiplication gets things larger, right? 3 times 6, well, I started with 3, I ended with 18 when I counted it 6 times. Case, for some reason, I had 3, I multiplied it by 2, 6, and I end up with 1. I end up with something smaller. So why might that be? What do we know about values of numbers and fractions? So I'm gonna leave us at that. But as always, thanks for your hard work and everything that continue to ask questions. That's that math norm that we consistently want to work with. Like if it doesn't make sense, questions until it does, because that's the best way for us to get the job done. And as always, thank you for your hard work, the best, and we'll see you next time.